Mm.
I found that on my word. I was like, yes.
You talking about OneNote?
To draw the pictures
Yeah, uh-huh.
of the bells and the whatchamacallit,
Hmm. Yeah, it most definitely it's a plus to have something like this. I guess I could have put nah. I could have put one right here. All right, so 3.1 is measures of central tendency. First thing you're gonna do is add up all of your values. I said first thing you're gonna do. First thing we're talking about is your mean. In statistics, mean is just another word for average. So if you know how to find the average of numbers, it's the same exact thing. They just call it mean in statistics. And so the first thing you would do is add up all of your values, then you would divide by the number of values that you have. So do a mini example. So we have the data set of 1, 2, 3, 4, 5, and we want to find the mean. Add them up. We have 5 data values, so we divide by 5. So that's 15 divided by 5, which is 3. All right. Questions on that?
nope.
Hold on 1 second.
Baby bone.
Sorry about that. um, All right, so we're looking at our median, which represents the middle value. So we're gonna list our data values from least to greatest. Where a lot of people make a mistake on this one is that they forget that first step. So please don't forget the first step or it will not come out correctly. So you list your data values from least to greatest. So I didn't mean to put 2 and 3. They pretty much are the same step. If the number of data values is odd, you're going to take the middle value because if you have an odd number of data values, then of course you have a middle value. But if the number of data values is even, if there are even number of data values, you do not technically have a middle value. So you're going to take the mean or the average of the two values that are in the middle. So let's make sure we're okay with how that works. A little bit too close. That should be good though. All right. So if our first data set, we have 1, 2, 3, 4, 5. We have 5 data values. So we have an odd number of data values. So here we have an odd number of data values. So that means we have a middle value, which is 3. And that is our mean. It was already listed from least to greatest, so we didn't have to worry about that. The next set, we have an even number of data values. Probably should do this. Put it right here. I don't want
So would 3 and 4 be the median for the second data set?
right, we will take 3 and 4 and find the average of it. So you take 3 and 4, add them together, divide by 2, and that'll be 3.5. And that would be the mean for the second data set. And if you notice that 3.5 is right in the middle of 3 and 4.
Okay.
Mm-hmm. Also, another thing to remember about the median, it'll come up later. The median, let's say separates. Oh, let's say splits, separates or splits. Yeah. So, separates the data. So that median is going to separate your data or split your data in half. So that's one thing that we're going to use the median for later on. It's the middle value, so it splits your data in half. All right. Let's look at the mode.
Quick question. Can you scroll up real quick?
Let me know when to stop.
All the way. Okay.
Let me know when you're ready.
All right, I'm good.
Oh, that's it. Okay. All right. Anything else? Anybody else before I go to mode? Don't let me move on if you need me to stop somewhere. Got it good. Okay. All right. So your mode is going to be the one that appears the most, the data value that appears the most frequently. So it is possible to not have a mode. It is also possible to have more than one mode. Bimodal. Bimodal is two modes. And let's see, is it polymodal or multimodal? I think it's polymodal. No, it's multimodal. Yeah. So multimodal is more than two modes. Right. Let's see. Okay, need an example. Okay, so if I just had these numbers for my data set 127, 8, 9, 6, 7, 5, 2, 9, 7, 6, 5, 1, 3, 4, 7, and I wanted the mode, that would just be 7. Whatever value shows up the most would be your mode. All right. Let me see. Fall resistant. One last thing out of this section. Let's do this. Okay, so the last thing out of this section is something we'll talk about in more detail as we progress forward. A summary of data is said to be resistant if outliers, in other words, very extreme values, if outliers to the data set do not affect it. So let's look at what I mean by that. Let's go. All right, so if I have the data set 1, 2, 3, 4, 5, we've already done this, but I just want to show you what happens when you interject an outlier. So we already saw that the mean was 3 and the median was 3 for this data set. But now, let's say if I have the data set 1, 2, 3, 4, 500. So of course this 500 is the outlier. All right. My mean 1 plus 2 plus 3 plus 4 plus 500. It's over 5 because we have 5 data values. That'd be 510 over 5, which would be 102. But the mean would still be 3. I mean, I said mean. Median. Said mean strong. But the median would still be 3. Talking about the middle value. So what this means is that, let me see, I'll show it like this. So that just means that the median is resistant to outliers. It's not affected by the implementation or the existence of an outlier. All right, questions before we look at 3.2. All right. All right, 3.2, measures of dispersion. So dispersion is the degree to which the data is spread out or dispersed. All right, let's go here. So the first calculation they give you here is the range, just your largest data value, smallest data value. So your range is just as simple as that. Your largest data value minus the smallest data value. Where's my definition? I just write this. Okay, so your standard deviation measures how far a data value is from the mean. Then your variance. Okay, so your standard deviation measures how far a data value is from the mean. Your variance is your standard deviation squared, and it's just another way to measure the spread of data. So this whole section, we're talking about measuring the dispersion or the spread of your data. These are other ways of doing so. We'll talk about how to calculate those in a second. Just give you a chance to write them down. All right. Yeah, we can do that. Let's go find it. All right. So this book does not hold you accountable for calculating standard deviation or the variance. If you want to just know how to do it, then I can take that, that question offline. We can discuss it. It can be a long and tedious process, especially when you go larger than 20 data values. It's one of those things where you don't have to create a chart, but it would be in your best interest to do so, because if you mess up on one data value, then the whole thing is shot. Um, and you would need that chart so that you can be able to go through what you would need it. It would be your best interest to create the chart so that you can go through each category and see where you may have miscalculated. Um, but this book doesn't hold you accountable for that process. So you don't have to pay for anything. There's a whole bunch of free things out there. You want to find yourself an app, calculator website, or something of that nature that will help you calculate the standard deviation and the variance. An example of that is easycalculation.com. Um, you can always just Google standard deviation calculators, Google variance calculators. Normally, if you Google standard deviation calculator, it calculates the variance as well. Normally, they go hand in hand, because like I told you in the previous statement, that your variance is just the standard deviation squared. So normally, when you find a standard deviation calculator, it also calculates your variance as well. But you want to find something that's reliable. You want to find something that you can depend on. So in other words, for an example, if I have, where we go, and what you want to be able to do is just type in the data values and hit enter. If you're doing more than that, then you're kind of doing too much. If you have to store values and, put them in this place and put them in that place and all the type of stuff like that. If you're doing all of that, then you're kind of doing too much. Making sure this is the one that I want. Okay. So just so you can check, the data set 62, 88, 77, and 68, your standard deviation is 11.3. As far as the application of the standard deviation, we're going to talk about that as we progress forward. But right now, we just want you to find something reliable that you can use in order to calculate the standard deviation and the variance. Oh, so that means your variance.
And you said we just put the numbers in and hit enter?
Yeah, if you're doing more than that, then you're doing too much, because there are a whole bunch of different things out there that will allow you to use in order to calculate the standard deviation and the variance. It's just that some things call for more work than necessary, because some apps has already done the work for you, and all you got to do is just type in the data values and hit enter. Like easycalculation.com, if you type in 62, type in 88, type in 77, and type in 68, and then hit enter, it'll just calculate the standard deviation and variance for you. There are some things, some calculators out here that you had to type in 62, store it in this value, type in 88, store it here, store it here. You know what I mean? You have to do a little extra. So I'm just saying, if you have to do more than typing data values in and hitting enter, then there are other things out there that will do it for you just that simply.
Sir,
Mm-hmm.
I added all those together and
Mm-hmm.
divided by 4,
Mm-hmm.
and it came to 73.
Uh-huh.
What did I do wrong?
You calculated the mean, you calculated the average.
Okay.
Yeah, remember, I want you to calculate the standard deviation and the
Okay.
variance. Yeah, though, yeah. So that you're going to either need the process, or you're going to need a calculator or app or website in order to do so. So
Yes, sir.
just to give you a heads up or an idea of what I mean, the standard deviation formula is So that's your standard deviation formula for your sample standard deviation formula. So it's more of a process when you're looking at this right here, that's sigma. That means the summation. So what you have to do is you take your data value. This is your data value. This is your average. And I will talk about notation in a second as well. You have to subtract the average from the data value, each data value that you have. Then you have to square each one of those. Then you add them together. Then divide by n. N is the number of data values that you have, minus 1, and then take the square root of that. So, like I said, most people don't care about the process because you're not held accountable for it. But if you want to explore the process outside of class time, just shoot me an email and we can talk about it. But once again, this book does not hold you accountable for the formula and knowing the process, but actually coming up with the calculation and the application of the standard deviation, which is more important than the calculation of the standard deviation. So we'll talk about the application, like I said, as we progress forward. Where's my sheet? Okay, cool. All right, so, okay, let's go into notation. All right, so when it comes to statistics and notation, you're going to have certain notation that's going to be applied to your population. And then there'll be certain notation that's applied to your sample. So the difference between the sample and the population, your population is the whole, let's say we talk about TCC, the student body is the population. The whole student body of TCC would be the population, and a sample out of that student body would be this classroom. So everybody in this class would be a sample of TCC student body. So the sample is just a piece or portion of the population. All right. So let's see. Let's look at some of these Greek letters. And what's going to happen is you're going to have certain letters that are specific to the population and certain letters that are specific to the sample. So when you see a certain notation, you'll know automatically that you're dealing with population versus the sample and vice versa. And they will expect you to know that. All right, so first set of notation, X is always your data value, whether you're dealing with the population or the mean. But mu, that's Greek letter mu. It almost looked like a U and almost like an M, but it's just Greek letter mu. That's the population mean. That's your population average. Then we have a lowercase sigma. Remember, I just showed you capital sigma. That's capital sigma, which represents the summation. And I kind of ran out of room. That means you're going to add up all your data values. But here we have lowercase sigma, which represents the population standard deviation. And then sigma squared is the population variance. Also, that's this regular capital N. That is the population size. All right, for your sample, X bar is your sample mean. And if you see any letter and a bar over it, if you had y, a bar over y, that would just be y bar. So any letter with the bar over it is just that letter bar. So X bar is your sample mean. Regular lowercase s is your sample standard deviation. S squared is your sample variance. And lowercase n is your sample size. So capital N population size, lowercase n sample size. Questions? Any questions? Any questions? So this, I believe, is a good place to stop without giving you too much in one day. So just to give you a heads up as to where we will be going moving forward, we have to finish out 3.2 and talk about the empirical rule. We don't do 3.3 in this class. Nope. And so we have 3.4 and 3.5, which 3.4 is, oh, that's not how you spell that. And summary. So we're gonna finish off 3.2, and the reason why I'm telling you this because I don't want you guys to let me go to 3.4 without finishing off 3.2. So I'm gonna give you a heads up. So hopefully, y'all, I won't forget. Even if I do forget, you guys will remind me. So we got one more thing in 3.2. There is no 3.3, but then we got 3.4 and 3.5, and I'm going to stretch this out a little bit because I don't want to do too much because I actually could next class finish this out, but I'm gonna try to hold this off for all of next week. Because like I said, I don't want to jump into another chapter real quick without giving you guys a chance to do everything you need to do in order to be ready for the next chapter. So next week we will do these 3 sections, and we'll be done with chapter 3, and we will go from there. Questions on anything I've said? Anything I've said?
Yes.
Yes.
What does that say on 3.55 number? Summing?
Summary.
Okay,
Yeah, I got a little lazy with writing it. Yeah. So don't forget next class. Well, this Thursday there is no class. Um, get those definitions to me, as soon as possible, so I can go ahead and put your grade in. I will be putting grades in this weekend. So once I put those grades in, if you haven't gotten it to me, then I will put a 0 there, but your 0 can be removed. So you got to make sure you communicate and get those things turned in. Then on Tuesday, we'll look to get into finish off chapter 3 and go from there.
thank you. Have a good weekend.
Thank you. You do the same. All right. If there's anything else, I will see you guys Tuesday.
Okay, bye-bye.
All right. Have a good one. All right. I see a chat.